Good morning, good afternoon, and good evening. Today we are covering the second subtopic of motion, which is also called motion. This is the core and supplement knowledge covered. So 1. Define and calculate speed. Speed is the rate at which an object travels a distance. Speed in meters per second equals distance, meters, divided by time, seconds. Average speed is just total distance, meters, divided by total time, seconds. And average speed units is meters per second also. Speed versus velocity. Speed is a scalar quantity, which means that it only has magnitude, which in this context is only the rate at which an object travels a distance. Velocity. Velocity is a vector quantity, meaning it both has magnitude and direction. Velocity equals displacement m to a certain direction divided by time, seconds. Example, if going north is considered a positive direction and going south is considered a negative direction, then a car going north at 75 meters per second would be written as positive 75 meters per second or just 75 meters per second, and the inverse, negative, for going south. So if we're going south at 75 meters per second, it would be negative 75 meters per second. Define and calculate acceleration. Acceleration is the rate of change of the velocity of an object with respect to time. Acceleration is also a vector quantity. Acceleration units meters per second squared equals final velocity, meters per second, minus initial velocity, meters per second, divided by elapsed time. This is a speed time graph versus distance time graph. The first graph we have here is a distance time graph. But most is, distance time graph. So when it's a straight line like this one, it means that it has constant speed. Flat means it's stationary. Steeper line means that it has a faster speed. Negative gradient means it's returning to the start. And then there's this one line that's not yet been covered here. It's a curve. If there's a curve, it means this is equal to increasing speed. Yeah. Now let's go to the speed time graph. So a straight line upwards is constant acceleration. Flat line is steady speed. Deceleration is just a straight line going downwards. Increasing acceleration is a curved line upwards, and decreasing acceleration is a curved line downwards. Calculating distance from speed time graph. Here we're given a speed time graph, and we have to calculate the distance. Distance is the area underneath. So let's try to draw this. Oof, sorry. Not yet used to my drawing pen. Here, we have to recognize the shapes first. We want to calculate the distance traveled in this whole journey. So we got two triangles. One rectangle and another rectangle and another rectangle. So to calculate this, rectangle is just side times other side with different length. So here 5 and this is 10. So this is equal to 50. This is also the same. This is 5 and this is 10, so 50 also. This is in meters. And then triangle is equal to base times height divided by 2. So for this one, it would be 20 minus 5. This is equal to 15. And this one here is equal to 10. So we substitute that. 15 times 10 divided by 2 equals 150 divided by 2 equals 75. So this is equal to 75 m. And let's look at this whole line. This whole line is equal to 20 for this rectangle times 10 here. That's equal to 200 m. And lastly, this other triangle, which has 20 as a height and 10 as a base, let's just substitute it with the base times height formula. Ten times 20 divided by 2 equals 100. This is equal to 100 m. Now let's just add all these values up. Plus 50 plus 75 plus 200 plus 100 equals 475 meters. That's the distance traveled. Acceleration equals the gradient of the line. So like in math, you learned that formula for gradient equals y2 final speed minus initial speed of y1 divided by x2 minus x1. So an example of this would be if you have I need to make it line straight. If you have something like this is for example a speed time graph. And this would be a straight line. This would be x1 and y2. Oh no, y2 would be right here. And x2 would be here. And y1 would be the same as x1 position. It would look like that. And then you just need to plug in these values. And then you get acceleration. An example would be this is equal to 20 speed. Let's just calculate the acceleration from 10 to 20 seconds. This is 20, this is 5. And then what we have here is 10 and 20. So let's plug it in. 20, which is y2, minus 5, which is y1, divided by 20, which is x2, minus 10, which is x1, 15 over 10 gives us an acceleration of 1.5 meters per second squared. Finally, acceleration due to gravitational field of the Earth is constant. Acceleration of free fall g for a body near to the Earth. Acceleration due to gravity on Earth is equal to 9.81 meters per second squared, or in IGCSE, they just round it up to 10 meters per second squared. So this is the last question here. At what speed did she cross the finishing line? A young athlete has a mass of 42 kilograms. On a day when there's no wind, she runs a 100-meter race in 14.2 seconds. The sketched graph below shows her speed during the race. First, we need to calculate the area here, this triangle area, so that we know what the distance traveled was in this area. So 8 times 3, we just plug it into the triangle formula. So 8 times 3 divided by 2 equals 24 divided by 2 equals 12. So this equals 12 meters. So you know this is 8 and this is 3. Now, we need to calculate the area here, which is the distance traveled in this area. I think it looks like a trapezoid because there's 2 parallel lines. There's a height. Yeah, it matches. It matches. So all we need to do now is plug it in to the trapezoid formula, the values. We know that this area here, because it's a 100-meter race, is 100 minus 12. And that's equal to 88 meters. So we plug it in and the values of trapezoid formula. So A plus B divided by 2 times height equals 88. And we can say that 8 could be A or B. So we just put 8 plus X, which is the unknown here. We don't know what this is. Just say it's X. Divided by 2 times the height, which is 14.2 minus 3, which is equal to 11.2. Equals 88. So what we do is we just divide this, like remember the divide area thing here? We don't really divide it, but the divide area, we times it to get rid of it. So times 2. So this becomes 176. And 8 plus X times 11.2. And then after this, we, times 11.2, so we divide it by 11.2. So 11.2, it removes that here, and then we divide this by 11.2. And what we get is 15.7. And now we have 8 plus X equals 15.7. Now X is the thing we need, so we take out 8 by minusing it. Minus 8. Minus 8. So X equals 7.7 meters per second. Yeah.